Alright, so this is where the point that we're at right here. I have this thing. This is a drawbar that I built. The threaded part goes into the collet. And then I have a 3/4 inch collet, a piece of 3/4 inch round bar. These are my soft jaws I have in here, so the soft jaws will deform against the round stock here and hold it in place. I didn't want to use my serrated jaws because it would just tear up this piece of bar stock. So I've tightened this down with a pair of vice grips, and so this is now one unit right here. So I was able to get the spanner wrench to go in here, and I used a lot of WD-40 and a lot of heat on this, so that would hopefully free up these threads that have not been opened in probably 60 plus years. So I did get this to pop off camera. I apologize I didn't have the camera rolling for that, but essentially I was just leaning on this really hard, putting a ton of pressure into it. And then a design flaw that I just realized with my spanner wrench here is it rotates like this. So just not a great design there. So I'm gonna have to fix that in the future. So I took a nut, put a nut here in the middle, and then that's the fulcrum point, and then that allows us to turn. So you see I got broken free. It took a ton of time with the propane torch and the WD-40, but that did break free. So this is honestly my first time getting into this, so you're going to see what's in here with me. So that was my drawbar. You see there wasn't a whole lot of meat there for it to catch against, but it did the job. I was surprised at how well that this spanner wrench works. Pretty simple design, but it worked pretty darn well. Saved me from having to buy one, and I'll build a version 2.0 that'll be a little bit prettier, a little bit better fit and finish. So my understanding of how these things come apart is this allows this bottom spindle to come out. There's two bearings in here, one up here and one on the front side. So as you can see right there, a lot of grease in there. I don't see a grease zerk on here, so I don't know if that's grease that came out from the bearing over time. And that feels like wax, honestly. That is some very, very dried grease. That feels like a candle, so that's the consistency of it right there. So I'm assuming that was from the bearing and it just gave out over time. So there is a snap ring. That's a little disconcerting. I don't know what that came off of. So the idea is this tire and board and padding here is going to support this. These are brass soft jaws, or sorry, aluminum soft jaws I have on here. And I'm not clamping on the groove way here, I'm clamping on the other sides of it, so I'm not going to be doing any distortion to it. Got that clamped on there nice and tight. Now it's just a matter of having my hand here. I'm lifting it up so I'm not driving it down, but I'm driving it out on a horizontal plane. That way I'm not causing any binding action in here on this bearing surface. There we have it. So here's a better look at what we're dealing with. As you can see, this gear is almost slid all the way off. So you have your gear, your bearing, and it's supposed to be high up on the shaft here, but as you can see, it slid the length here down. This is what I found floating around in my in the grease when I cleaned it out. And this clip is designed to sit right there and clip on that shaft there to keep this gear from sliding down. So very happy I took this thing apart so I was able to find this before something catastrophic happens. Say I have this thing in, running at a high RPM and this shaft decides to walk off, it would probably destroy the whole internal workings here. So gears so far look pretty good. I haven't seen any damage to them, so we're going to get this cleaned up here and we're going to see if we can get the shaft back on and this retaining clip put back onto it. Right here, I'm grinding in the groove that the snap ring sits in. This will allow more contact area between the shaft and the snap ring, which will hopefully prevent the snap ring from being pushed off again in the future. All right, we are all done with the rebuild on this. I want to go over a couple quick takeaways I learned with this rebuild. Number one is the bearings in here are a very tight pressed-in fit. It took a lot of force to get them out. And on the same note, when it came time to reassemble them, freezing the bearings and heating up the casting really did help. Just that little bit of shrinkage with the bearing in the freezer made it go in a lot smoother. Second takeaway was the dry grease. I underestimated how much the dry grease would feel like the bearings were bad in it. So when I pulled this out of the box and I started spinning the shaft and it felt really crunchy, I instantly thought the bearings were bad. Once I got in here, got everything cleaned up, super smooth. So just because it feels crunchy if you get one of these, doesn't mean that it's a bad bearings. It could be just dry grease and they're gumming up the gears. And the third takeaway was that snap ring. So I know now to look for it, but when I first got this, you would have seen it that this R8 adapter here would be protruding out past the edge of this casting here, about an inch or two. And if you see one of those protruding out like that, that tells you that that shaft, this R8 adapter here, is being pulled out from that gear set, and that snap ring is popped off. The way I fixed this on mine is I just took over the lathe and used my Dremel with the cutoff wheel to grind that groove in a little bit deeper, and I was able to put a one size down smaller snap ring on there, so there's more contact surface area between the snap ring and this shaft, so it can help better support that load that's being pressed against it, because when you're pulling this up, you're trying to pull against that snap ring. So hopefully you guys got something out of this video. If you haven't already, please hit the subscribe button. It helps the channel out. And thank you guys for watching. Have a great day.